Hello, everybody. My name is Dave Newton. Thanks for joining us for today's webinar. We're going to just give it a couple of seconds before we begin so everybody can get loaded into the webinar. We have quite a few people here today. So give it a few seconds more and we'll see when the attendance meter stops increasing and we'll get going. Okay, looks like most people are on. Still have a few trickling in, but we'll get going. Thanks for joining us for today's webinar, Next Generation Slot Floor Optimization. It's a fascinating topic and really kind of a cutting edge topic. So we'd like to thank Jason Figa and Stacy Barron for joining us from Ncube. A couple of quick things before we get started. We are going to record the webinar, so you can get the recording anytime. And we'll send an email tomorrow that will have information on where to access that. Jason will be taking questions and Stacy will be kind of screening them. So if you have questions, just click on the questions icon and type them in and they'll go through those at the end of the webinar. And then as the last thing, there'll be a very short, just 3 questions evaluation survey at the end. We would love to get your feedback and comments. So if you could just give us 1 minute at the end to fill that out, we would really appreciate it. So again, thanks for joining us from all over the country and even internationally. And I'll go ahead and turn things over to Jason.
Hey everyone, so I'm Jason Figa. I'm excited to be speaking to you today, telling you about the latest, and in my opinion, the most exciting developments in slot floor optimization. Today I'm going to be talking about how to optimize your games and adjust their holds to maximize your slot revenue. So a little bit about me. I'm Ncube's CEO, founder, and actually its chief inventor. I regard that as actually my most important role. I have quite a deep background in optimization-focused AI systems, which will be prominent in the talk today. It goes back 23 years, actually, when I first started building AI systems literally from scratch. I was an early pioneer of AI in the gaming industry also, introducing our Ncube's RealAI slot floor optimization product in 2016. And I personally design all of our RealAI modules, often with a little bit of help. So I specialize in artificial intelligence, optimization, segmentation, forecasting, all good stuff if you happen to be in the gaming industry. And interestingly, I'm also an associate professor of astrophysics at the University of Manitoba. I'm currently in my academic office because I'm teaching a course on stellar astrophysics right after this one. At Ncube, we like to say we've been doing AI before it was cool. I mean, literally, I've been doing this for 23 years in one form or another. I already mentioned our AI-powered slot floor optimization solution, which we largely built in 2016 and made available in 2017. We do slot floor right sizing, slot hold optimization. Baked into that product, there's also a lot of player behavioral modeling and segmentation, as well as what we call 360-degree player models and forecasting. Really exciting stuff where you can take everything and anything you know about your players and build it into a comprehensive model to understand their behaviors at your casino. We also do some consulting and special product projects, including some applications in fintech outside of the casino industry. Today, I'm going to be focusing on the top 3 here in my list, really getting into details about slot floor optimization and our latest thing, which is slot hold optimization. So before I get to that, this slide is a cartoon I actually made with ChatGPT back in 2024. I don't know about you all, but it's easy to start getting into a little bit of AI burnout. Every software product on the planet seems to be adding AI features, and a lot of them are a little bit nonsensical. So here I've got some spreadsheet or something with a sort button. Now of course it's an AI sort button. So this is a little bit facetious. I'm a huge fan of AI. Obviously, I wouldn't have devoted the last 2.5 decades to it otherwise. However, along with the public's interest in AI, also comes a lot of marketing buzz, and there's a lot of good products out there, and also a lot of junk. Your mileage may vary between different products. So today, what I'm going to do is I'm going to show you some really impactful AI systems that you can actually use to make more money at your property. So in this seminar, it's loosely divided into 4 parts. The first part I just call not all AI is equal. So I'm going to be here addressing different types of AI and kind of contrasting what we do at NCube with large language models like ChatGPT that most of you are probably more familiar with. We're going to be talking in part 2 about optimizing slot floors with numerical AI, and I'm going to be drawing a careful distinction between that and what tools like ChatGPT do. Part 3, we get into the latest and possibly the most exciting part of the talk. Can your players detect increases in slot hold? I mean, this is a profoundly challenging problem in the casino industry, and it's been the source of a great deal of controversy, which I'll be discussing. And then part 4, I'm going to show you how you can actually increase your slot hold and carefully monitor for changes in player behavior to make sure you haven't gone too far with it. So we're going to cover a lot of ground today. So buckle up and here we go. So part 1, not all AI is equal. So, given that this is sort of an AI-focused talk, I'd be remiss not to talk a little bit about large language models, which have become incredibly popular in recent years. So here I'm talking about ChatGPT and their competitors, including Copilot, Gemini, Claude, and DeepSeek. These are remarkably powerful generative AI tools for all kinds of language-related tasks. So you can build chatbots with these. They can answer questions. You can have full-blown discussions with them. I use them a lot just to bounce ideas off of, and augment my own knowledge in areas that are outside of my own area of expertise. You can write code with these things, which is fantastic. I mean, not detailed code. You certainly can't build whole applications with ChatGPT. However, you certainly can, help use them to take away some of the drudgery by writing little snippets of code that you can fit into larger applications. So along with the rise of large language models, especially ChatGPT, most people today equate artificial intelligence with large language models, but there are many other kinds of AI, and some of them, including the ones I'm talking about today, are more relevant to casino analytics. While we're on the topic of large language models, I thought I'd mention multimodal systems. These are fairly new, and what's really cool about these is that they're starting to blur the line between large language models and other artificial intelligence tools, which I find really exciting. Essentially, things like integration with image analysis and image generation. For example, you're going to see lots of illustrations and cartoons in my talk that I actually made, in ChatGPT. ChatGPT didn't make that. It simply designed a prompt for me, which it sent to an image generation tool. So these kinds of integrations are becoming increasingly common and increasingly deep in the software. You're starting to be able to do things like analysis and plotting of data, maybe a little bit of regression, forecasting, clustering, et cetera. And like I said, you can help it to write and run computer code. So things are, the line between large language models and other kinds of AI are becoming increasingly blurry, and that's actually very, very exciting. With large language models, again, just some cautions and practical limitations. One thing everybody knows if you ever played with one of these things is that they hallucinate. If they don't know the answer to your question, they will make stuff up. Also, not always great for data privacy. Just a caution, you should never, ever upload sensitive data to a public large language model. If you need to do that, you can get private instances for most of these tools where it's a lot safer to do that. Applied to math and statistics, well, this is where they really don't do so well. Obviously in my own work, I'm constantly doing math and statistics and really high-end coding. They make a lot of math errors. You should never ever trust anything a large language model tells you in regard to mathematics or statistics without human verification. So you have to be able to tell, when it's making stuff up and when it's actually leading you down a good path. So as a scientist, I'm pretty skeptical, and I'm pretty good at doing that. These tools also have memory limitations. So if you're thinking to just upload some big table into ChatGPT and have it, come up with some insights for you, I mean, you could try that, especially if you have a private instance of ChatGPT. But they max out at around 100 megabytes, which is actually quite small compared to the data sets that I usually deal with from the gaming industry. In cases like that, it's better to ask the LLM to help you write code to analyze data. And I actually did some experiments with that about a year or two ago, which was the focus of another seminar that I gave online. When it comes to artificial intelligence, my general advice is use the right tool for the job. So my little cartoon on the right, which ChatGPT helped me make a couple days ago, shows somebody trying to hammer a nail with a screwdriver. I mean, with perseverance, you could probably get it done, but it's the wrong tool for the job. So large language models, despite the rise of agentic AI systems, they are becoming increasingly capable, but fundamentally, these tools are about language, not math and data analytics. However, our industry makes money fundamentally with math, not with language. So the most impactful tools for the kind of analytics that we do in casinos are based on math, not language. That's a key point in this talk. There's different kinds of AI. We want the ones that are good at math. Lots of business applications and all data modeling applications require advanced optimization. And there's a deep connection between optimization and artificial intelligence. Whenever you're doing anything in AI, behind the scenes, there's actually a little optimizer that help train that neural network behind the AI system. The stuff I'm talking about today, it's not based on neural networks. It's a different kind of AI that is singularly focused on finding the best solution to whatever problem you want to throw at it. Mathematical AI systems are designed for this. Large language models simply are not. Your data in this industry is amazing. It's actually why Stacy and I got into the casino industry. Casinos collect detailed data about your games and your players, and you archive it, and you can access it. And you should use this data to maximum effect to improve the bottom line of your operation. So your data can be a valuable asset, but there's a caveat. Data really only becomes powerful when it's transformed into actionable knowledge via analysis. A pile of data is nothing on its own, but when you dig into it, you start analyzing it and finding insights, that's when it becomes powerful. So AI, it's just the latest and greatest tool to accomplish this. However, not all AI is equal, and you want to use the right tools. So there are powerful AI systems, as I'm going to show you today, which you can combine with traditional analytics and simulations. And these are deeply impactful for modeling your data and optimizing whatever it is that you want to optimize. Okay, so moving on into part 2 of the talk, we're going to get into some of the details of how to optimize slot floors with numerical approaches to artificial intelligence. Before we get to that, I'm going to give you my origin story. 23 years in the making. So back in 2002, I was a young research scientist with Canada's National Research Council out in Victoria, BC. And this institute, it's all about astrophysics, which is kind of my other passion, right? And so I was the only theorist that they had ever hired for this job, and I had all kinds of theoretical ideas and mathematical models, and I wanted to take the opportunity to fit it to the kind of data that the institute collected. So I started doing this, and very quickly I realized I was in over my head because all of the classic tools that I could deploy for modeling data would absolutely fail when I tried to fit them to my models. All data modeling is fundamentally optimization. I was a little disheartened at the time because these tools were failing, but like any scientist, we like to think outside the box, and so I decided to build better methods. So at the time, I embarked on my AI optimization project. Figured it'd be maybe a 6-month project to build something really cool so I could solve the problems that I'm interested in. 23 years later, I actually still develop the same tool and improve it constantly, and it's found its way outside of astrophysics into other industries, including cancer radiotherapy, engineering applications, and of course, and most importantly, our work in the casino industry. So I'm fundamentally an optimization guy. And when you're an optimization guy, you translate lots of problems into optimization. So here's a list of some of the problems that we can address using extraordinarily powerful AI approaches to optimization. Anytime all of these orange words here are optimization words. How can I maximize my slot, table, or bingo revenue? What is the optimal mix between slots and table games? What is the best mix of games? for my casino. How do I optimally allocate the space between slots, tables, and bingos? How do I move machines around to maximize revenue? How do I optimize my slot hold? And then, kind of more on the player side, how do you maximize customer engagement? On the financial side, you could consider doing things like finding the optimal budget allocation for each of your departments, and so on and so forth. Everything that we really care about in business always ends up reducing to some kind of an optimization problem, because you want to do something better or the best, so you can beat out your competitors and ultimately generate the most profit, while also keeping your customers, your players, happy. So in the talk, I'm going to be focusing on the ones at the top of the list primarily. The ones at the bottom are really interesting, and I've been thinking a lot about those too. That might be a topic for another seminar in the future. So before I get into slot optimization in general, I want to say a few general things about optimization. So in the casino world and really the business world in general, everyone thinks they know what optimization is, but it's often used pretty loosely. When you talk to to somebody in our industry, or really in business in general, about optimization, they might think that means looking at data and deciding on an optimal plan. Maybe they're going to play with some numbers on a spreadsheet to kind of explore some what-if scenarios. Maybe they'll do some projections or look at some key performance indicators. Maybe they want to minimize their expenses or something like that. But fundamentally, you're just kind of playing around with numbers on a spreadsheet, moving things around, to find a better solution. You might visualize performance metrics to make a decision. Graphing things. Visualization is a great tool for understanding data. You might even do things like look at maps or other data to optimize a new business location. So we do all kinds of things that really are optimization. And I don't mean to diminish what's on that bullet list. This is optimization. However, there are powerful AI-powered methods that can be applied to these kinds of problems with far greater capability and precision. A human being simply can't explore enough possibilities to truly find the optimal scenario. So this is one of my ChatGPT cartoons here, trying to illustrate what optimization is like. Okay, so here I've got some model. Okay, so my model is this big complicated machine, and what's happening behind the scenes is complicated. We might not even know in detail what's happening, with all of the interactions and mathematics inside of that model. But it's a model, and in any model, you have certain decision variables. So these are all the knobs and levers on the machine that the people at the bottom of the screen are playing around with here. And I decided that this person up here is monitoring the machine. So they're basically looking at what I would call the objective function. Okay, essentially, they're seeing the effect of what all the knobs and levers do, and they're recording it, and that's essentially the objective function. So this person up here wants to maximize something. So think about decision variables being kind of the knobs on the machine. The objective function is the thing that you're trying to accomplish. Now, you could just kind of do this by hand, have them play around, try a bunch of random knob positions here. You might make some progress. However, when you add AI into the mix, you can do something much more significant. Essentially, the monitor up here sends feedback to an AI system, and the AI system suggests new settings for all the knobs and dials on the bottom. And you go around and around this loop. You essentially iterate on the process, and eventually, by very carefully selecting your decision variables, you can arrive at the best solution to your problem. This is AI optimization in a nutshell, and it is truly powerful. How does AI make it possible, when a human being can't? The issue is that every kind of optimization problem, which includes modeling any kind of data, becomes extremely difficult as the number of decision variables is increased. This point is often underappreciated, even by people in the scientific world. We have a name for it though. We call it the curse of dimensionality, and it's an expression that the size of your search space and the number of possibilities just explodes exponentially as you add new decision variables to a problem. And it very rapidly becomes impossible to try all possibilities. Moreover, it becomes easy to get stuck in false or local minima because you haven't done enough exploration because the space is too big. And even constraints become harder and harder to satisfy as you have more and more decision variables. So this is where AI comes in and helps you out, because the key then is to use numerical AI techniques and advanced computing to search intelligently to find the best solution. For most problems, it takes me about 100,000 to about 1 million different iterations to find usually the true global maximum of my function. And I'll get to that in a moment in the context of slot optimization. So basic objective and requirements for slot optimization. Your objectives are really simple. Maximize the total uplift in slot length across your floor by adding carefully curated new machines, or maybe doing conversions, removing less productive machines, moving machines around on the floor to make the best possible use of your floor real estate. You might want to right size your floor, either adding, making it a little bigger or a little bit smaller in terms of the number of machines. And now the latest thing that we've added to this is carefully adjusting your slot holes. To do this, it requires a lot of granular data. The key data that I typically work with is player session level data. Literally every transaction that's happened on a slot machine for a period of typically about 1 to 5 years, although we can go a little shorter or a little bit longer depending on the scenario. It also requires a lot of very detailed player behavioral profiling. You can't optimize a slot floor unless you understand your players, and we have machine learning methods that can do that. We segment the games. We group them together according to their internal properties and their performance. And to make this all work, you need several powerful optimization-focused AI systems all working together as a single unit. So it's a complicated problem, but it's one that we can do using modern optimization-focused AI methods. So if you're optimizing slot floors, you can take a bunch of different approaches. It is easy to find an okay or a good slot floor configuration, but it's much harder to find the best one. A lot of casinos, will deploy sort of like rule of thumb approaches, and these are utterly inadequate. You might have internal rules like, well, we're just going to replace all the machines, some number of percentage points below floor average. We might want to put the top performing machines in the highest traffic locations. This might be good advice, or it might not be. But the point is, it's not truly data-driven unless you've actually explored all the possibilities. So if you're doing this, you're not leveraging AI, your rules are probably not optimal, you're probably leaving money on the table, and you probably don't know. So this is what can happen when you take simple approaches to optimization, often based on rules of thumb. You get stuck in what you think might be a good solution, but there's a far better one down here. So the kind of optimization that I do, it's agent-based AI optimization. So essentially what you have is you've got lots of searchers hunting around in the space of possibilities, and they talk to each other. This is much more complicated than simple optimization approaches, and requires more advanced solvers. So in this case here, the idea is that you actually add some randomness to the search. You want to have it searching around the space, and randomness is for technical reasons actually important to that. But every time an agent finds a better solution, it communicates it to the rest of the agents. And pretty soon what happens is somebody, one of my agents finds the best solution, and it doesn't take too long before all of them end up down here agreeing that this is the best solution. You can't find this one sometimes because you get trapped in this one with simpler approaches. So these ingredients are utterly important for agent-based optimization. Now, this is a really simple example. Obviously, I coded this up in a few minutes. What happens behind the scene with massive problems like slot optimization is a lot more complex. So slot data, it's large, it's detailed, and it's rich. Typically, what we work with is player sessions. That includes the player card game, the game start and end time, coin in and out, and win. We also include uncarded play when available, and we have methods of adding it back into the data, even if it's not explicitly in your sessions. We need a slot master file, essentially looking at, enumerating all the game properties that you have, things like hold, the volatility, which will usually actually calculate directly from the session data. More on that later. Manufacturer, denomination, cabinet type, max bet, number of reels, really anything and everything you know about your games. The more you know about your games, the more AI can help find the best possible solution. We also include things like monthly reporting, financials by game, including uncarded play. These are huge data sets, especially the player sessions, and they are, and that's actually a good thing. AI is fundamentally data hungry, and so this industry is a perfect match for artificial intelligence because you have so much high quality data. The way I think about slot floors, I think about it as kind of an ecosystem. So what does that mean? You have players, you've got machines, you've got tables, other amenities, with complex interactions between all components. Everything, in a sense, is connected in a casino. So if every component fundamentally affects every other part, you have kind of like this complicated web of interactions linking everything together. So you make a change somewhere, and that change ripples out through the rest of the casino, affecting everything else. So to truly understand a slot floor, which is a prerequisite to optimizing one, you have to have a very integrated understanding of the floor and how it interacts with guests. And that is the key to generating an uplift in revenue. Now, the good news is that artificial intelligence, it's fundamentally designed to discover patterns and understand complexity. This is too complicated for really any human to understand on their own. But you turn an AI loose on this, it certainly can find patterns and understand that complexity if you program it and give it the right target. Just a few things on how I typically look at slot data. I call this my ebb and flow plot. This is all about occupancy. So you see the daily cycle of patrons coming to the casino and leaving, and it goes on and on from day to day. And if you squint your eyes a little bit, you might be able to identify a weekly cycle. Casinos tend to get busy on the weekends, et cetera. And there are even some longer-term cycles that can be seen in the data. This is an example of visualization. This is does not feed directly into the AI optimization, but it is useful for looking at the data. This is a representation of the raw data that goes into the system. So here what we're looking at is we're looking at kind of this rich tapestry formed by occupancy data, coin in and coin out, and each of these stripes here represents a day. Okay, so we have kind of the daily ebb and flow that I showed on the previous slide, and each of these pieces is actually like a little line segment representing a player session. So it's a graphical way of understanding all the data that feeds into the AI system. This is interesting to look at, but of course the AI itself doesn't just look at the pictures; it actually does the math. So if you want to model a slot floor, at least with our system, it requires 3 different AI systems. The first AI profiles players into behavioral groups with similar gaming interests. The key point here is understanding the fluidity of gaming choices. You take away somebody's favorite game, in all probability, they're going to shift to another game. At some level, that's the game that we play. We want to get them to shift from low-performing content to higher-performing content. But the way you do that is by understanding their fluidity and what different player groups are likely to shift to. We segment games into groups with similar characteristics and performance. This is optional for all but the smallest casinos. We do this. And then finally, we link the player side of the equation with the game side of the equation, and we hunt for the best possible model while respecting all constraints supplied by the operator. So it takes 3 different AI systems, and they all have to work in tandem to make this work. So it's really simple to state what we're trying to do with slot optimization. Optimize the entire floor as a single interconnected system. You don't have to break it into parts. You don't have to optimize individual games. You don't have to optimize individual game segments. The goal is simple: make the most money from your slot floor by treating it as a single monolithic interconnected system. So we want to maximize the total net revenue, usually adjusted for lease and capex costs. In this system, there are hundreds of thousands of decision variables, and that's where the AI comes in. A key point is that if you do this right, You don't have to add in any ad hoc rules, assumptions, or tuning. You don't have to add in rules like take off everything below a certain, below a certain percentage below floor average. Nothing like that goes in. You simply turn the AI loose on it. You tell it what you want to do, optimize that entire floor as a single system, and you let it do its thing. That's really the magic of it. In the process, it's going to simulate about 1 million different alternative slot floor configurations, and at the end of the day, it will have arrived at the best possible option. What this involves is adding machines, removing them, moving them around on the floor. You can keep the number of machines static or allow expansions or reductions. It really just depends on the instructions that you give it. It has to obey all constraints from the operator. For example, every casino has this one game that your best player will only play, and you can never remove that, and that's cool. We just have to know about it. Similarly, you might have games that are so old they're going to die anyways, and you have to remove that from your floor. So constraints like that are important. It makes the problem a lot harder, but we can do that. In the process, you project the total slot win, accounting for capex and lease costs. And of course, what you always want to do is you always want to balance lease content versus own content if you're the type of casino that actually has leased machines. And so this is massively complicated. You can only do this if you have truly powerful optimization-focused AI systems. If you don't have that, you end up making a whole bunch of assumptions and ad hoc rules, and the solution just isn't as good from a mathematical point of view. This is what a run looks like to me. This is the rudimentary interface that I see when I'm doing a slot optimization run. And this goes for a while, and interestingly, I cannot advance this, but anyways, you can see what's happening here. It's forming a trade-off curve between the number of changes that we have to implement and the net uplift. The net uplift in the floor. Notice that this says negative win uplift. That's a technical point. My optimizer is a strict minimizer, so to maximize uplift, I have to minimize the negative uplift. It doesn't matter in the end. But you get this nice trade-off curve here. Every star on here is in a sense optimal. We can look at it after the fact, and we can ask the casino. At the end of the day, we discovered here. You have to replace. You can replace up to 60 games and get a net uplift, and that's going to get you around 5%, 5% uplift. But you can look at it after the fact, explore every one of these stars, and at the end of the day, you choose the best one corresponding to the number of changes that they want to make. A change, by the way, in this case is an addition and a removal. So the number of purchases in this case, it's probably like 20, 25, or 26 at maximum. I'm simulating here a smaller casino. By the way, this isn't actually real data. It's very similar to real data though. I included this slide. It's kind of a throwback to pandemic days, which I'm sure most of us would like to forget. Back in those days, there was a drive to, often turn off every other machine or close sections in casinos to minimize the spread of COVID. So I did a little bit of work during that terrible time period for a casino lender, basically a bank that, that was financing casino operations. And I did a very straightforward Monte Carlo simulation here, and I was able to demonstrate that for most casinos, you don't really take too big of a financial hit until you remove around 40% of your machines. You see a little bit of decline, but it doesn't start getting really bad until you take off about 40% of the games. Most casinos, it turns out, are built for maximum occupancy, not average occupancy, so you can always shave a little bit off the top, and the fluidity of gaming choices will cause those players to move to other content. Even carefully curated slot removals can almost always result in an uplift in win. I didn't see that here because this was just random removals. When I do an optimization of a slot floor, if the goal of a casino is to reduce the number of games, I can almost always find increased revenue by taking games off the floor, by targeting games that will result in a shift of the players to more productive content. At the end of the day, whether you're just removing content or removing and adding content, there are always numerous opportunities to achieve uplift. The challenge is to find them and specifically find the best solution. So I'm going to move on now to the newest stuff that we're really excited about at Ncube. Can players detect changes in slot hold, which leads in part 4 to a strategy to actually accomplish that. Now, next only to curating the hottest games that your players love, slot hold is the most impactful parameter that can change your slot profits. Essentially, increase the slot hold. You keep a little bit more of the money that players bet. You can potentially increase your profits. Now, the thing is, when you turn up your slot hold, players, for obvious reasons, don't really like that. And so the danger here is what happens if players notice that you've increased your slot hold and decide to spend their money at a competing casino instead, or simply not come because they don't feel like they're getting good value for their money. This is a very interesting and challenging problem. So when, if we want to look at how slot hold impacts win, the slot hold, of course, varies between games. And in fact, most games offer several different hold options. At least modern games, you can actually change the hold in the game, not continuously, but they're discrete options that you can pick from. So I'm going to introduce the idea of RTP, or return to player. That's simply the expected payout divided by the total bet after a whole lot of play has happened on that game. The hold is 1 minus the RTP. And just for an example, if I have a hold of 10%, then my RTP is 90%. And for every dollar that a patron gambles, the casino is going to keep around 10% in the long run. Obviously, lots of variation for individual games or small numbers of games, but in the long run, you're going to make about 10 cents for every dollar spent if your hold is 10%. Sometimes the player wins, but the host, on average, wins a little bit more, and that generates your slot win. Slot holds usually range from about 2%, typically, things like card games, to about 15% for fancy, flashy new games. Higher slot hold means a greater share of the money bet is retained by the casino. Slot hold is an incredibly controversial topic, and as far as I can tell, this goes back decades. So on the one hand, you've got academics, primarily the group at UNLV, that tell us players cannot detect slot hold due to the high volatility of most games. Essentially, you bury the slot hold inside of the volatility. And they argue players would have to play for an unrealistically long time to figure out that you've increased your slot holds. Operators, on the other hand, say not so fast. Players will eventually figure this out, and when they do, they will punish you for your greed by going to a competitor or simply not coming. So that's the controversy, and this has remained unresolved for decades. I love this quote from Buddy Frank. It's from GGB magazine in 2017. Buddy says in that article, in my experience, this increased profitability after a slot hold increase lasts about 180 to 270 days, and then there's a tailspin, despite what some analysts believe our guests aren't stupid. Why do I like this quote? Because in this instance, I agree more with Buddy than the academics, and I'm going to show you why. The viewpoints aren't actually contradictory. So when academics, academics, of course, know their statistics, and they got the right answer, but I think they asked the wrong question. So it is true, and I verified this, that individual players do have a hard time detecting a change in slot hold. Okay, but what about a community of players who are connected by some kind of a social network? They talk to each other. This is especially relevant to locals casinos or any casino with an active social media community. At least in this possibility, there's the possibility of players sharing information with each other and maybe figuring out that you've increased your slot hold. So there are two important questions. Number one, can a community of players learn that you've increased slot hold, even when an individual player cannot, according to the academics? And number two, can you increase your slot hold carefully to generate more revenue while also keeping your players happy? And I'm pretty sure most people have figured out that the answer to two is yes. And I'm going to show you that very shortly. A little bit on RTP distributions. This really drives home the point for why it's so hard for players to detect slot hold. So this is real data from one particular game. And what I did is I looked at the probability of an actual return to player after 25 games. So kind of a medium short, maybe even short slot session. But you can see it's a wide distribution. Notice I have to plot this logarithmically because the distribution is so wide. You just can't see anything unless it's logarithmic. For those of you less mathematically inclined, honestly, don't worry about it. It's not important. So what I did is I took the same game, and in my computer, I turned up the hold by a factor of 2. I literally doubled the hold to 24%, which is absurdly high. And not very many casinos are going to have games at 24%, but it makes a point. Look at these distributions. They are almost identical. They overlap each other so strongly that it would be hard to tell the difference. So fundamentally, this is what's going on with games with high volatility. The hold itself becomes so blurred and obscured by this wide distribution that you can't figure out that the peak of the distribution, it has a certain value until you've played an absurdly large number of games. And we can go further though with this. What if I look at, in this case, it's a different game, but we look at one game and we look at what happens to that return to player distribution as we increase the number of games. So here I've got 25 games, 50 games, 100 games, and at the bottom here, 10,000 games. And you look at these distributions, and if you pay attention to the actual scale, you'll notice that it's narrowing. As you play more games, the distribution narrows, and that's how casinos make money, right? Because as a whole, your player community plays a huge number of games. That distribution narrows, and it eventually converges to what the RTP is claimed by the manufacturer. Okay, but the point is, even after 10,000 games, this is still a pretty wide distribution, and you still can't reliably determine the RTP or equivalently your hold. Not many players play anywhere close to 10,000 games on one machine. They can't tell. They will not be able to determine the hold on this game by simply playing it for any reasonable amount of time. That's the paradox of the slot floor. Individual players cannot detect a game's hold or change to it without playing a crazy number of games. However, the community as a whole plays far more games than any individual. So if players could somehow share information, the community could detect a slot hold increase. But how can that happen without an organized effort by your players? That's the challenge. And it turns out the answer is really simple. Your players are kind of working together. Casinos are social spaces. Players are not isolated, and they talk to each other about their wins and losses. To be specific, I'm not talking about collusion or organized teams here. I'm talking about friends talking about how they did at the casino last night. So it's just simply communication between friends or maybe on social media. So players have an opportunity by talking to each other to learn from each other, and this helps shape their opinions about the relative tightness or looseness of your slots. It happens organically. You don't need any organization for this to occur. And I can simulate it. And I did this. About a year ago, I took a very careful look at this problem, and I made simulations on my computer of a network of connected players. And I decided that most players have on average about 10 friends, and when they win or lose, they communicate that to their friends. It turns out the 10 friends doesn't matter. It works just fine with like 5 friends or 3 friends or 20 friends. But the idea is that I did a simulation of connected players, who talk to each other, and they learn from their own wins and losses, and also from their friends. For those of you who know a bit of stats, these are Bayesian learning simulations. Bayesian statistics is basically a framework for how beliefs should change when confronted with new data. Being simulations, this took many hours of runtime on a powerful workstation for each case that I looked at. But it was worth it. It was extremely revealing. So here's one of my simulations here. This is what happens if there's no communication between your players. So in this case, all the players are completely independent. And you can see I've got curves up here representing the player's belief about the probability of winning at Casino A, which is blue, or Casino B, which is red. The red casino is the one that increased their hold. And what I'm looking for here is a clear separation between the red and the blue, and clustering towards the right. When all these bars at the bottom cluster to the right, everybody believes that red casino is the bad guy who increased their slot holds. And you can see it kind of starting to happen, but like, I'm up to almost 200 visits here. That's a lot of visits. It takes a long, long time. Players really aren't figuring this out in any reasonable amount of time. Why is that? Because they're not talking to each other. So let's let them talk. And bang, look what happens. Within about 20 visits, I've got clear separation between these curves. That means that the players have actually learned that the RTP at red casino is higher than at blue casino. They've all clustered down here. Basically, everybody in the community agrees that red casino has a higher hold than blue casino. They learn by about, typically about, they start learning about 20 visits in, and it's complete by 50 visits. So the power of communication in this network, in this very unorganized fashion, actually dramatically changes the results. So a reasonable criticism to this would be to ask, what if players aren't rational? Okay, so I can build that into my simulations. I basically modified my Bayesian update rules to build in irrationality by overweighting a person's own experience. And I think we all do this to some extent. What happens? I expected these simulations to fall apart when I did this. No, it's actually worse. It actually happens faster. It only takes about 10 visits before they figure it out. The only downside to this is that if they're not perfectly rational, very, very occasionally they'll get the wrong answer. But essentially what we have here is an echo chamber where beliefs are being reinforced and amplified by players talking to each other. A few other findings were that even small changes in the average hold are potentially detected by the community after about 10 or 20 visits. And most importantly, once those beliefs become entrenched, they're irreversible. I actually did experiments where I, partway through the simulation, when things were starting to converge, I flipped them. I made blue casino the one with the higher hold, and I reduced the hold at red casino, and it didn't matter. So once beliefs become entrenched in a player population, that new information no longer matters. Reversing course has no effect. You've done brand damage to yourself, and it's possibly permanent. So if you are thinking about increasing your hold, you should be cautious about doing it. You need to proceed carefully and get this right. And that's what I'm going to show you how to do in part 4. Can you increase your slot hold safely? Yeah, you can, but very, very carefully. Bottom line is more volatile games are safer. Remember I showed you that the hold kind of hides within this envelope of volatility. So it makes sense that the more volatile games are safer. To get those volatilities, you have to do Monte Carlo simulations using player session data. You can't just use the volatility index that the manufacturer gave you for a bunch of different reasons, which I'll talk about in a moment. You can also focus on games that have less play, but that's not going to be great because you're not going to get as big of a revenue bump from them. You should always carefully monitor what happens after an increase using AI and statistical tools to find the earliest possible indications that players are figuring this out and migrating away from games with increased slot hold. So this is the same graph I showed you a little while ago, but now I've kind of labeled some parts on it. The red line here is break even. Okay, and if you're on the right side of the curve, the player wins by a factor of 10 or maybe even 100 if somebody hits a jackpot. And on the left, the player loses a bit of money. Okay, so this is what an RTP ratio curve looks like, distribution looks like. And the key point is that if you have a certain amount of volatility in your game, players have an opportunity to win, even though they still lose on average. This is a little simulation I did of an extremely low volatility game. And what you notice is that it's absolutely boring. The player always loses. And in a game like this, you could easily estimate the slot hold by the rate at which they're losing money. Even a single player could detect hold on this game. Nobody would ever play it though. Who wants to play a game that you inevitably lose at? A more exciting gameplay is this one here, which has exactly the same hold, but I turned up the volatility. This is more like what I would consider a medium volatility game. And the cool thing is that in this case, even though players lose on average, every once in a while, one of them wins substantially. The volatility obscures the slot hold. You could not look at this as an individual player and figure out my volatility. So I introduced recently what I call the HISI index. Okay, this is a very simple measure. It's the volatility index divided by the change that you're contemplating in the hold. Volatility here, volatility index here, it's a non-standard volatility index for a variety of statistical reasons. It's not the normal one that you might read about in the literature, and it is certainly not the manufacturer's often simplified volatility rank. Some manufacturers will give you like a 1 to 5 scale to measure their volatility. This is calculated from player session data using some pretty advanced statistical methods required to get an accurate, stable result from player session data. But fundamentally, it's easy to understand. You know, the higher the volatility and the lower the change in hold, the higher your HISI index, the safer it is to do that. It makes sense. So what you want to do is you want to increase slot hold in several tranches, always starting with the highest HISI values. Work your way down. So you pick a few games that you're going to increase the hold on with the highest HISI values, and then you go into a monitoring phase, and then you do another tranche of games later on if you were successful with the first one. This is relatively safe. Where does the extra money come from when you do this? I mean, won't players just run out of their, bottom out their wallet and leave? No. There are players that are time limited who have elastic wallets. These are the players who basically play until they get bored or run out of time. They're willing to spend a little bit more. Real players are always somewhere on the spectrum between budget limited and time limited. And the key is that machine learning techniques can segment players and model the elasticity of their wallets. And we use that to calibrate the sensitivity of different player groups to hold. We have this multifaceted monitoring protocol to make sure that results are being achieved and players are not migrating away from games. So this is the first thing. It's the simplest one. It's simply slot tracking. So again, here I've got the occupancy, the coin in, and the overall slot win over time. So the bar here is when the change was introduced. We're going to normalize. Sometimes we'll normalize this against the rest of the slot floor to remove the effect of any externalities. Smoothing and data filtering techniques can help find the signal in the noise, in the statistical noise. But in this data set, which I cooked up, this is not real. I cooked this up a few days ago. You can see here that after we implemented a change, there was a decline in occupancy and coin in. You see that happening. You turn everything back the way it was because players are noticing, and you've got a problem if you leave that on. That's the simplest thing you can do. Second thing you can do is more advanced. We can use forecasting tools. So I have a very powerful multi-series forecasting tool, which basically combines occupancy, coin in, and win data and models them simultaneously as a whole. Combining data like this increases the forecast accuracy, essentially, because they're all effectively correlated with each other. When you do this, you might see stability, which is good, or you might see a decline. And if you see a decline happening in the prediction of what's to come in the next 30 to 90 days, you got to reverse course and stop what you're doing. So forecasting is an important tool for understanding what happens after you change your slot hold. A little brief aside here about a very popular forecasting tool called Facebook Profit. I tried using this once a couple years ago, and I really didn't like it for a bunch of reasons. But fundamentally, if you look at how it's described on Facebook's website, it says Profit is a forecasting procedure implemented in R and Python. That's fine. It's fast and provides completely automated forecasts that can be tuned by hand by data scientists and analysts. I see this. That's a huge red flag to me as a scientist. What that means, you don't like the answer, change it by hand. When you see hand tuning in a piece of software, especially an AI-based technique, that is often a symptom of poor numerical technique and very weak tools. Anytime you have to tune the results of your AI-powered software to get the result that you want, that is not good. When you see that, your software is doing less than you think. So I don't particularly like this tool. Maybe it has some applications. There are other things I don't like about it as well, but I'm not going to get into that now. But it is another example of a forecasting tool, and largely the motivation for me building a more advanced method. Number 3, getting back to our monitoring protocol, look at the player flows. Search for groups of players that are migrating away from hold increased machines. This is more sensitive than just looking at slot trends, because you'll see a migration away from games in the players before you'll see it in the game statistics. The key here is a very player-centric view looking at the distribution of your target players. So what are they playing and how much? Are they moving to other content? This requires statistical analysis of player groups. You can't look at individual players and see anything because individual players are too random and too chaotic. So if you start seeing migration away from hold increased games, you stop immediately. You never ever allow us to progress the migration of players away from the casino as a whole. The good news is you'll see it happen to the games that you change the hold on before you see it happening to the casino as a whole. And it's an opportunity to intervene and reverse course if necessary. Finally, optimize your slot hold. You can build a calibrated, you can calibrate a segmented player sensitivity model, and once you've done so, you can optimize it. You can only calibrate a model if you've actually seen some migration. If you don't see any migration away from the games that you increased, you're good. Increase your hold further or increase the hold on some other machines. That's fine. However, once you start seeing a little bit of an effect that players are moving away from those games, you can turn that into opportunity because you can use that to calibrate a model to see how sensitive those players are to an increase in slot hold. So you can answer questions then, what is the critical hold increase where migration first occurs? And number two, what slot hold increase ultimately maximizes your slot win? Very important questions. And it's the first time there's ever been an opportunity to actually optimize slot hold. This is a review of the monitoring methods that that I talked about. In the interest of time, I'm not going to go over this in any detail. But number one, track your slot performance, make forecasts using powerful forecasting methods, model your player flows, and calibrate a sensitivity model. Those four things are the cornerstones to monitoring what happens after you've increased the slot hold. This is my summary slide here. Only 4 points. Number one, advanced AI-powered optimization methods allow you to optimize a slot floor as a single interconnected system. You don't need any ad hoc rules of thumb or assumptions or anything. You simply give it a target. I want to make more money from my slot floor as a whole. Let the AI figure it out. Number two, I think we've resolved a long-standing controversy between the academics and the casino operators. Individual players can't detect slot hold, but connected communities of players can. Number three, operators should worry about brand damage when increasing slot hold, especially in locals, casinos, markets, or any casino that has a strong social media community. And finally, the good news is slot hold can be increased with relative safety using our new HISI index, as long as you also implement careful monitoring using advanced and very sensitive machine learning and statistical tools to understand how your players are responding when you make this increase. So that's it for the talk. Again, I'm Dr. Jason Figa from NCube. I'd be happy to take a few questions if there are any.
Okay, so there's just a couple questions here in the interest of time. So first one here is how do these methods scale depending on the size of a slot floor? Are they applicable across all types of slot floors, or how does that work?
Yeah, any slot floor with a reasonable number of machines can be optimized. We've worked with as small as I think about 100 and 130 or so games, all the way up to 3,000 or 4,000. As you go to larger properties, there are more opportunities because there's more for the AI to explore. But even with small properties, we've seen 5 or 10% uplift in overall profits. The very smallest I'd want to look at is probably around like 50 games or something like that. And anything below that, I would not segment the games. I would just treat them as standalone. But yeah, there's opportunity for casinos of all sizes.
Okay, another one is for casinos that want to test a hold increase, what's a realistic timeline from initial monitoring to seeing an impact in play?
You need at least a month to collect data to see if anything is going on with players migrating away from games, preferably more like 2 or 3 months. By the time you get to 3 months, things start looking pretty clear, especially when you look at the flows of players. Oftentimes the actual slot statistics can be pretty chaotic from one day to another. You may not know exactly what you're looking at, but the more advanced tools, especially the player flows, and to some extent the forecasting, can start detecting things after a few months. I like to start looking at it after a month and usually I'm pretty sure what's going on after about 3.
Okay. Also, can you speak to any case studies or numbers that you can throw around in terms of tangible improvements to revenue or savings?
Yeah, so we did a white paper on this before we got into the slot hold optimization. So this is just simply about adjusting content. We were able to find in the white paper was about I think it was about a 5.5% increase in revenue for a very, very small casino, 130 games. Okay, now this was in the very early days of this for us at NCube. We improved our product a lot since then. If I reanalyze that data, I can easily find them 10%. 10% is relatively straightforward, and in fact, we have what we call our 1-to-1 rule. Generally, for 1% change out of content, I can usually find you about 1% increase in revenue from your slot floor. That seems to hold pretty well across casinos of all sizes, anywhere from the very smallest, like with 100 and some games, right up to several thousand games.
Okay, that's all I have for questions, sir.
Okay, well, if there's nothing else, I just want to thank everyone for.
Sorry, one just came in.
Oh, okay, sure.
How many games percentage on the floor would you realistically? Would you realistically have to change for the index to accurately represent the effects of your changes as opposed to outside forces?
Okay, so I think this is about adjusting slot holds. You can really start with any number of games. In some of the testing that we've been doing, we're starting with 20 or 30 games, and the key is you can monitor what's happening on those games, and you always do them in tranches. So that's really the first volley in a larger program to increase holds across the property. Once we're convinced that nothing is happening, but yeah, I mean, you can start with just a few percent of your game and work out from that, and that's the safest way to do it. Always break those changes in hold into relatively small tranches of games. Implement and monitor, implement again, monitor, etc., until you've actually achieved your goals. This is the kind of thing that if you want to be careful, you have to be patient and be absolutely committed to the monitoring protocol that I outlined.
I think this is kind of like a two-piece question as well, though. So let's say, like, with the hold, increasing hold as well as slot floor optimization in general, I think there's kind of a second part here in terms of like how to distinguish the effects of those changes versus any external effects that are impacting the casino.
I get it. With just adjusting content, I mean, it's a little bit challenging, frankly. If a casino completely changes, how they interact with their players, you can have bumps in revenue or declines that are unrelated to adjusting content. With adjusting holds, what you can do is you can normalize those effects out by comparing what's happening in the games you've increased the hold on to the casino as a whole. So effectively, we can use normalization methods to remove the effect of externalities in that case.
Okay, great. There's another question that came in. How do you segment your customers between time-bound and money-bound?
That's challenging. I have a really cool AI system that I call Bonsai, which is excellent at finding those kinds of patterns. So essentially, I assume that a player is somewhere in that range, and I effectively group them together based on how they've operated in the casino. Essentially, every player, specifically players who come to the casino frequently, you can see how much time they've spent and how much money they've spent. A player who always spends $100 at the casino is definitely money bound, right? A player who only ever spends 2 hours at the casino is time bound. So you can kind of sort it out. I mean, it's a little fuzzy, it's a little foggy, but we have tools that can that are extremely proficient at segmentation, and at least for a large population, teasing out which ones are wallet bound and which ones are time bound.
You segment them based on their behavior that you see in the session data?
Yeah, it's based on session data. Essentially looking at what they've actually played, how long they've played, and also how much money they've spent over a particular visit. Behind the scenes, we don't just work with sessions. We actually break those down into individual visits to the casino. And you get a whole lot of information by just looking at how an individual player behaves on an individual visit, and combine that with a bunch of different visits. You can see patterns, and we can deploy segmentation tools to sort them into buckets, essentially, ranging from the most wallet-bound players to the most time-bound players.
And I think that's it for questions. I'll check one more time. Oh,
There's a question about recording, so we'll send that information out tomorrow. Everyone will get an email tomorrow with the location where they can access the recording.
excellent. Looks like that's it for questions.
Yeah.
Okay.
Okay.
Well, no, thanks.
Go ahead. Thank you very much, Jason and Stacy. We really appreciate it. We really appreciate everyone's participation. So hopefully we will see a lot of people exploring the new world of slot optimization. Thank you very much. Bye-bye, everybody.
Thanks a lot, everyone. Bye-bye.